In 2004, astronomers pointed Hubble's 2.4-meter mirror toward a patch of sky so empty. It looked like a mistake. No stars. No nebula. Nothing. But for nearly 2 weeks, Hubble stared into that darkness, patiently gathering whispers of ancient light that had been traveling for billions of years. And when the images were finally combined, humanity saw something no one expected. A window into the universe's childhood. A single frame that rewrote the limits of the observable cosmos. The Hubble Ultra Deep Field. Inside a region smaller than 1/10 the size of the full moon, nearly 10,000 galaxies emerged, each one a sprawling island of stars, dust, and cosmic history. Some were so distant their light began its journey 13 billion years ago, long before Earth even existed. The Ultra Deep Field wasn't just a photograph. It was a time machine, revealing spirals twisting like cosmic pinwheels, glowing elliptical giants, and faint blue clumps where the earliest stars were being forged. For a generation, this image became the edge of the universe. But even this legendary view had limits. Hubble's mirror could gather only a fraction of the light needed to reveal the faintest galaxies. Its sharpest vision faded in the red end of the spectrum, where the universe hides its oldest secrets. As space expands, ancient light stretches and shifts deep into the infrared, far beyond what Hubble can see. Dust posed another barrier, thick, cold clouds that swallowed visible light and erased entire populations of galaxies from Hubble's view. And the Ultra Deep Field's tiny footprint, just 11 square arc minutes, was like looking through a keyhole at a vast, unexplored mansion. Were those galaxies rare? Were they common? Did they cluster together or drift alone? The answers remained locked behind the limitations of Hubble's technology. Over the years, astronomers pushed Hubble's data to its absolute edge. But the universe wasn't done hiding. The oldest, reddest, dustiest galaxies, the ones that held the earliest chapters of cosmic evolution, were still invisible. A new kind of telescope was needed. And when the James Webb Space Telescope arrived, everything changed. At the heart of JWST is a 6.5-meter, gold-coated mirror, nearly 3 times the width of Hubble's, with more than 6 times the light-collecting power. It wasn't designed to replace Hubble, it was built to go where Hubble simply couldn't, deep into the infrared, where the earliest galaxies hide behind dust and time. As the universe expands, light stretches, turning redder, softer, and harder to detect. This redshift pushes ancient signals far outside Hubble's reach. But Webb is built for exactly this challenge. Using its near-infrared camera, sensitive from 0.6 to 5 microns, and the powerful mid-infrared instrument, JWST can pierce cosmic dust, expose newborn stars, and reveal galaxies that formed when the universe was only a few 100 million years old. Together, these instruments transform invisible wavelengths into a richly detailed timeline of cosmic history. This leap wasn't just engineering, it was strategy. Teams led by Caitlin Casey and John Cartault pushed for a new kind of survey, one that combined extreme depth with massive scale. To make it possible, Webb's segmented mirror had to align within nanometers. Its detectors cooled to just a few degrees above absolute zero. Custom data pipelines had to be built from scratch. Every movement, every exposure, every tiny adjustment was optimized for discovery. And then, the survey began. The Cosmos Webb survey set out to map the universe in a way humanity had never attempted. Over 250 hours, JWST scanned a region about half a square degree, roughly 3 full moons placed side by side. Inside this mosaic, astronomers cataloged nearly 780,000 galaxies. Not estimated. Not simulated. Real galaxies, each with its own stars, dust, gas, and history. For comparison, Hubble's Ultra Deep Field showed 10,000 galaxies in an area 1/10 the size of the Moon. Cosmos Webb covers 80 times the area and is nearly as deep. Every corner of this field reveals galaxies stretching back 13.5 billion years, their light born when the universe was less than 300 million years old. Suddenly, galaxies Hubble missed, massive, red, dust-choked giants, now filled the frame. Even the faintest smudges, long hidden behind dust or stretched beyond visible light, became visible. This wasn't a snapshot. It wasn't a sample. It was a cosmic census. Patterns began to appear. The Cosmos Webb mosaic revealed the universe as a connected landscape, filaments, clusters, and deep, silent voids. These colossal structures stretch across millions of light years, shaping galaxies the same way mountains and oceans shape life on Earth. Along the filaments, galaxies gather, collide, merge, and sometimes ignite in brilliant bursts of star formation. In the crowded intersections, clusters glow with thousands of galaxies packed together, twisting each other through gravity's pull. Meanwhile, the voids, vast cosmic deserts, hold only a few lonely galaxies drifting through empty space. For the first time, astronomers could see how a galaxy's environment shaped its destiny. Graceful spirals lived in calmer regions. Chaotic irregulars crowded the filaments. Massive, quenched galaxies clustered densely in cosmic cities. This map didn't just show where galaxies are. It revealed why they are the way they are. Then came the surprises. In the heart of the mosaic, astronomers found the Infinity Galaxy, a luminous figure 8 formed by two disk galaxies colliding 8 billion years ago. But what stunned scientists wasn't the shape. It was the center. Inside the merger were three supermassive black holes, two at the galactic cores, and one extra. Sitting off to the side, embedded in shocked gas. Its velocity matched the surrounding material perfectly, evidence that it formed right there during the merger. This discovery rewrites the rulebook for how black holes grow. More surprises followed. Galaxies that shouldn't exist at this stage were everywhere. Massive, quenched giants at a time when everything should be chaotic and star-forming. Beautiful spiral disks and barred galaxies at redshifts where theory predicts only violent, irregular forms. Mature galaxies rotating calmly billions of years earlier than expected. The early universe wasn't young and messy. It was organized, mature, and evolving far faster than our models allow. Then JWST shattered another record. Two galaxies, JADE's GSZ 14-0 and JADE's GSZ 14-1, were identified just 280 to 290 million years after the Big Bang. Not guesses. Not maybes. Their distances were confirmed with clear spectroscopic signals, including the unmistakable Lyman break. Even more shocking. In one of them, astronomers detected oxygen emission, proving a full generation of stars had already lived and died. The early universe wasn't slow. It was on fast forward. Star birth. Star death. Element formation. Galaxy growth. All happening at breakneck speed. Cosmos Webb has thrown the cosmic timeline into chaos. Models must be rewritten. Assumptions must be questioned. Simulations must be rerun. Galaxies formed faster. Black holes seeded differently. Star formation quenched earlier. Dark matter assembled quicker. Yet this massive survey covers only a tiny fraction of the sky. Millions, maybe billions, more galaxies remain hidden in the darkness, waiting for their stories to be told. The universe is stranger, faster, and far more complex than we imagined. And with every new mosaic from Webb, we're forced to rethink everything we thought we knew. In